Hey everyone, Mr. Reeves with you yet again, and we are continuing our look in lesson 16.3 on unit rate as slope. So in the previous video, I went through the four representations of a proportional relationship: the verbal representation using words, graphs, tables, and equations. And I tried to show you how they all relate together to represent the same relationship. All right, so now we're going to look more specifically at investigating the unit rate as slope and then use that to compare relationships that are given to us in different forms as graphs, tables, equations, or maybe even words. All right. So they said a storm is raging on Misty Mountain. The graph shows the constant rate of change of the snow level on the mountain. All right, so just a reminder, if something has a constant rate of change, it will make a line. It will be linear. Whoops, let's get a new one here. All right, there we go. Okay, so we have a linear relationship right here. You can see it's a straight line. And since it's a straight line that goes through 0, 0, we know not only is it a linear relationship with a constant rate of change, but it is also proportional. Proportional relationships on a graph always form a straight line and go through 0, 0, or the origin. All right, now they're asking us to find the unit rate. So we have the snowfall on the y-axis and we have the time on the x-axis, and the question is, how fast is that snow falling? All right, now remember, the unit rate, as we've discussed, can be found by finding the slope of the line. You can find the slope of the line you could find the unit rate by finding the slope on the line. And remember, you can find the slope on the line by using any 2 points you want to. Now, they have encouraged us to use the point 1, 2 right here, and the point 5, 10, which is right here. So those are the points that they have asked us to use, but you can actually use any 2 points you want to. But I'll go ahead and use the points that they asked us to use. So I'm going to go up. That is my rise, and then I'm going to go over, and that is my run. Whoops, a little crooked there. All right, and then I'm going to count that our units are 1, 1, 2, 3, 4, 5, 6, 7, 8. So our rise, which is equal to our change in y, is equal to 8. All right, and our run is 1, 2, 3, 4. Our run, which is our change in x, is equal to 4. So our slope, which is rise over run, is going to be 8 over 4, which is 2. Now, what does that mean? That means we have 2, what? What is our change in y? It's inches, right? 2 inches per, what's our x units? Hours. 2 inches per hour. So it says find the unit rate. I did it right up here. There is the unit rate. All right. And I just want to point out to you again that you could have used any 2 points you wanted to. All right. So for example, if I start right here, if I go up 2 and over 1, sorry, it's hard to do these little arrows. Up 2 and over 1, will it give me the arrow? Nope, it's not going to give me the arrow because it's too small. All right, but you could go anywhere on the line and go up 2 over 1, and you will land there, right? If we had gone this way, all right, we could have gone, what, up 10 and over 5, right? Up 10 and over 5, that point right there. And again, you will see in a proportional relationship, change in y over change in x will always equal y over x in a proportional relationship, right? If you take this point, 1, 2, right? Do y over x, 2 over 1. What do you get? You get 2, right? If you do that next point, 10, 5, what do you get? 10 over 5, which is 2. So as I told you before, change in y over change in x equals y over x for a proportional relationship, which means that the slope is equal to the constant of proportionality, which is k. All right? And it's the unit rate. It's amazing. Math is amazing. Isn't math amazing? All right, so how fast is the snow falling on Misty Mountain? It is falling 2 inches per hour. That's the unit rate. That is the constant of proportionality. That is the slope. All right, okay. So one of the things that they're going to ask us to do is they're going to ask us to make some comparisons here. Here's just another example, right? You can see here we have the table, and they actually asked us from the table to make the graph. So that's what I did in the previous video. We started with the table and then we made the graph. Again, just a reminder, it may be hard sometimes to plot the points that are on the table onto the graph. So you try to find the ones that you can plot. So again, this graph here goes by 2's and this one goes by 2's as well. So the ones we could plot, 2, 4, 6, 2, 4, 6, 8. That point would be right there, right? And then also we could do 12 and 16. 12, right? And then 2, 4, 6, 8, 10, 12, 14, 16. So you notice that's the points they chose to use, right, for their finding the slope. You want to use the ones that are easiest to use. You can use any 2 of them. All right. And then if you go from 8 to 16, there's our rise of 8. And if you go from 6 to 12, there's our run of 6. So our slope, right, rise over run, again, change in y over change in x is equal to, sorry, let me make that a little better. Change in y over change in x is equal to 8 over 6, which simplifies to 4/3. So what does that mean? That means exactly what it says right down here, that the slope and the unit the rate of the graph are equal. Therefore, 4/3 cubic feet per second is the unit rate and the slope. It is also, I'm going to keep hitting on this, it is also the constant of proportionality, right? So that means that k would equal 4/3. And again, take any of these, 4 divided by 3, 8 over 6 is 4 divided by 3, 12 over 9 is 4 divided by 3. They all simplify to 4 divided by 3. K equals 4/3, right? So they didn't ask you, but if you were asked to write the equation of this line right here, the equation would be y equals 4/3 x, right? Because remember, it's y equals kx. So if k is 4/3, y equals 4/3. So here is our equation. Here is our table. Here is our graph. Those are the 3 representations. And in words, we can use the unit rate and say that the water is going at a rate of 4/3 cubic feet per second, or we could say 4 cubic feet every 3 seconds, right? So this would be an example of the rate, 4 cubic feet every 3 seconds. 4/3 of a cubic feet per second is the unit rate. Remember, in a unit rate, that second unit has to be 1. All right, so again, this is all the different ways to represent a proportional relationship. All right, what about this one? Tomas rides his bike at a steady rate of 4 miles every 6 minutes. Graph the situation, find the unit rate. Okay, so they have given us right here, they've given us the verbal description of this proportional relationship. 4 miles every 6 minutes. Okay, this is a steady rate. This is a proportional relationship. So I immediately know that 0, 0 is going to be on this graph. It's going to contain the point 0, 0. All right? So let's see. Actually, you know what? Let me make a table right here. All right, let's go ahead and model this with a table. All right, and he's going to ride 4 miles every 6 minutes. So if you see the distance they've put on the y-axis, right? So miles, and this is minutes. Okay, if we were to label this, this would be our x. Oh man, I can do a better job than this. All right, here we go. We have x and we have y, and we have distance and we have time. And the distance is in miles and the time is in minutes. Okay? All right, and we're going to make a table, and we know, let me go ahead and draw in a line here. Let me drop that arrow off. All right, so here we go. And we know, and maybe I can, that's a nice slanted line I had there. Maybe I'll make these a little more straight. All right. Traditionally, my students have always given me a bad time about these lines when I draw them. Okay, we know that if he rides 0 minutes, he will go 0 miles, right? 0 minutes, 0 miles. And he goes 4 miles every 6 minutes. So he's going to go 4 miles and 6 minutes, right? Well, if I do it again, what would I have? I'd have 8 and then 12. And if I did it again, what would I have? I would have 12 and 18. And if I did it again, 12 plus 4, I'd have 16. Add another 6. What do I get? I get 24. So here is the table version. Again, this is our verbal or our words. Here is our table. Let's go ahead and make the graph. All right, 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's 4, 6 right there, right? 8, 12, 5, 6, 7, 8. All right, and then we have, wait, 6, 7, 8. Make sure I go straight up. All right, there's 5, 6, 7, 8, 9, 10, 11. Oh no, we're going to go off, right? 12. 1, 2, 3. Did I go straight up? Okay, there we go. So we're actually one above because 10, this is 11, and this would be 12 up here. All right, so those are the only ones that are going to fit. I'm going to go ahead and make a dashed line here, and I'm going to throw an arrow on the end, and let's make it red, shall we? Okay, so I'm going to go through those. They should line up if I've done them correctly. Not too shabby there, Mr. Reeves. All right. So if we were to take a look at this, what is my slope? Again, my slope is my rise over my run, right? How much did I go up versus how much did I go over? Let's see here. Let's drop this. So if I do this, no, I'm not going to use blue. I'm going to go up there and over there, right? So how much did I go up? I went up 6 and I went over 4. So my slope, my rise is 6. That's my rise, right? My run is 4. But that simplifies to what? 3 over 2. In fact, if we went here, and let me use a different color, if I went up 3 and over 2, do you see how I'm on that line right there? Up 3 and over 2, that gets me there as well on the line. So the slope simplifies to 3/2. Remember, the slope tells us the unit rate. So what does that mean? That means he rides 3/2 of a mile, or 3/2 miles, actually, because it's 1.5, isn't it? So let me change that. 3/2 miles. One more time. 3/2 miles per minute. All right, 1.5 miles every minute. Okay? All right. So last thing we're going to do on this video before we finish it up is they're going to ask us to compare some situations going on, and they're going to give us different representations. I love these problems. Can I just say I love these problems? They give us different representations, and then they ask us to compare them. All right, so give the slope and the unit rate. All right, so these ones actually are the same. This is just a graph for George, and this is a table and a graph for Akiko. So that's not what I was looking for. All righty. All right, you know what though? Let's go through and do this anyway. All right, give the slope and the graph and the unit rate. All right, so slope is rise over run. Now remember, with slope you can use any 2 points that you want to. All right, make sure you look for a point that's on the line and on the grid. So there's 0, 0 right there. And how about, wow, well, if you look very carefully, you got to be super careful, because that point looks like it's on the grid and that point looks like it's on the grid, right? But if 10, 10, well, no, that's not on the grid there. Here we go. So as I'm going up, it sure looks like that one right there, huh? All right. So this would be what, 12, 10? Now, one thing you can do to see if you have the right point, try repeating it. All right. If I go up 10 and over 12, if I do it again, right? 2, 4, 6, 8, 10, 2, 4, 6. Oh, we're going to be off the graph. All right, so I'm just going to have to trust that I got a correct point here. I'm going to call this my rise. I'm going to call this my run. All right, if we take a look on the graph, what do we have here? We have 10 and we have 12, right? So our slope is 10 twelfths. But 10 twelfths simplifies if you divide both of those by 2 to what? 5 sixths. So what does that say? That says George or Jorge, I'm not quite sure which one it's supposed to be. The unit rate would be what? The unit rate would be 5 sixths of what? A mile per hour. And if you take a look at what does it say? He goes 5 miles every 6 hours. And if he goes 5 miles every 6 hours, guess what? He goes 5 sixths of a mile. Yay, I was right. I'm so happy. All right, what does that tell you? If we went up 5 and over 6, we would be on the line as well. All right, again, going up 5 would be hard to do. It would be 2, 4, 5, and then over 6, and there we are on the line as well, right? Or we could even go up 15, right? There would be 15 right there. And how much would we go over? We'd go over 18. We should land all the way over at 18. See how that works? Awesome. Isn't that awesome? Oh, math is awesome. All right, so this time they gave us the table and they gave us the graph. All right. So they're asking for, again, the slope and the unit rate. All right. I'm going to be smart this time. I'm going to look over here at the table, and I'm going to look at this point. Do you see how it has the point 8, 10? Do you know what that tells me? That tells me that I can go up 10 and over 8. Look at that. So easy when you use the information you're given. Up 10 and over 8, right? So the slope is 10 over 8, which when you divide by 2 simplifies to 5 over 4, which is right there, isn't it? Again, what does that tell me? If I can go up 10 and over 8 and be on the line, I could go up 5 and over 4, and I would also be on the line. Whoops, kind of crooked there, but you see that point right there? Okay, so we would have the point 5, 4, excuse me, not 5, 4. 4, 5 is on the line, and so is 8, 10. Remember, slope is rise over run, so the y comes first on the top. With ordered pairs, the x comes first, so sometimes it's confusing. All right, so what does that mean my unit rate is? That means my unit rate is 5/4 what? Miles per hour. All right. So Jorge was going 5/6 of a mile per hour. right? A Kiko is going 5/4 miles an hour. So if I said who's going faster, well, it would be a Kiko, right? And if I could superimpose this graph on this graph, do you see how this line is steeper, right? The slope of this line is steeper than the slope of that line. In fact, what a great idea, Mr. Reeves. I'm going to go 10. Remember 10, 8, 10 is on this graph, right? 2, 4, 6, 8, 2, 4, 6, 8, 10. All right, I'm going to go ahead and draw a Kiko's line on that same graph. And then you can see, right? Okay, the red one is a Kiko. No, I'm not making fun of a Kiko's name. It's just fun to say. A Kiko is going at a faster rate than Jorge or George, right? This is Jorge. So if the line is steeper, it indicates a greater unit rate, right? 1 1/4, 1.25 is greater than 5/6, which off the top of my head, I'm ashamed to say as a decimal, I couldn't tell you right now. I should be able to tell you that as a math teacher. All right, again, finding the slope from a table, right? We want to write an equation. The equation is going to be y equals k times x, right? Because the slope is equal to k when you have a proportional relationship. All right, change in y over change in x. So take a look here. This one went up by 15. This one went up by 30. This one went up by 30. This one went up by 1. This one went up by 2. This one went up by 2. Remember, you can use any points you want to. So if I were to do the rise over the run, or the change in y over the change in x, all right, I could either do 15 over 1 if I did that one, or 30 over 2. Do you see how they both simplify to 15 over 1? All right, so 15 over 1 is the slope, but the slope is equal to k, so the equation is y equals 15 over 1 or 15x, which totally makes sense because take a look at these y's. They're just that number times 15. 6 times 15 is 90. 4 times 15 is 60, and so on. This one right here, if we take a look, plus 6, plus 6, plus 6, that's our change in y. All right, 16 to 32, that's plus what? 16 plus 16 plus 16. So our slope is equal to 6 over 16, but that simplifies. Divide them both by 2. What do you get? You get 3/8. But 3/8 is equal to our k, right? Our constant of proportionality. So our equation would be y equals 3/8x. All right, this one's a little harder to see. If you multiply 16 times 3/8, you'll get 6. But just a reminder, remember, for a proportional relationship, the change in y over the change in x is the same as y over x, right? 90 divided by 6, 15. 60 divided by 4, 16. 6 divided by 16 is what? 3/8. All right? Okay, I could keep going and going and going because this is so much fun. But again, if you're asked to compare, and I did it right here, if you're asked to compare them, all right, what you want to do is find those unit rates, and you can find that by finding the slope, the change in y over the change in x, the constant of proportionality. And now you should know how to get that constant of proportionality, whether you're looking at the table, the graph, the words, or the equation. All right, I hope this helps you out. If you need any more help, don't hesitate to ask. Till next time, bye.